It's actually
live.
Hello, everyone. Hello, welcome. We're all set. We'll just give it a few more seconds for everybody to get settled in. We see people are still coming in. A lot of people coming for this really exciting webinar. There is a lot to talk about. We'll just give it just a few more seconds so everybody can join us. And then we will start the conversation. It's going to be, we've had a really great turnout, and really there's a lot of really interesting things to talk about. So welcome everyone. I'm still seeing people coming in, so I'm gonna give it a few more seconds before we start. And then of course everybody can join as we do the introductions, which I believe we can start now. So welcome everyone to this webinar on Avio's blueprint for success and how metal 3D printing is revolutionizing aerospace. Every year, the technological and economic leap to space shrinks. From just 12 companies a decade ago, we have over 300 today. And the race to lead the next era of space exploration is on. Companies like SpaceX and Blue Origin have paved the way, but many organizations are quickly emerging with groundbreaking innovations. So enter Avio. With a rich history dating back to 1912, they're harnessing the power of advanced manufacturing in their Additive smart factory to unlock new advances in space propulsion. Specializing in space launchers, solid and liquid fuel propulsion systems, and payload adapters, Avio intends to bring space closer than ever before. Dive into the future with Velo3D's Roberto Esposito and Ricardo Tosi. They'll be joined by Avio's lead manufacturing engineer, Alberto Campi, to unveil the latest in metal AM. Together, they'll showcase how Velo3D's cutting-edge solutions are driving unparalleled innovation and flexibility in aerospace manufacturing and supply chains. Hello, everyone, and welcome to this fantastic webinar session organized in collaboration with Velo3D, a company that in just a few years has completely revolutionized key adoption segments such as space and energy. We have a lot to talk about today, so let's get started. Just a quick introduction for myself. My name is Davide Scher. For those who don't know me, I am a journalist and market analyst, and I am the co-founder and CEO of Voxel Matters, a leading global media and market research company that specializes exclusively on the additive manufacturing or AM industry. Voxel Matters is one of the leading news and editorial portals. We're trusted by AM professionals all over the world. And via Voxel Matters research, we conduct extensive market research on and publish reports on all the core segments of additive manufacturing, including space, including verticals such as space and energy, for example, but a lot more too. Today, we're here to learn and explore how Velo3D's unique metal AM technology helps space companies by driving unparalleled innovation and flexibility in aerospace manufacturing. And we will look at this fundamentally important subject with support from Avio, a very significant player for those who are not fully familiar with the company in the European space industry. They are the makers of the Vega launchers, the ESA's, the European Space Agency's satellite launch vehicle, designed to send payloads into low Earth orbit. Avio is a prime contractor for the European launcher Vega and subcontractor for the Ariane program. The company is active in the field of technological research. It carries out projects in collaboration with 14 Italian universities and 10 foreign universities and research centers, which are aimed at the continuous improvement of product and process technologies. Avio is taking this challenge to innovate space head-on, and is doing this with support with Velo3D's end-to-end manufacturing solution and Velo3D's technical sales and support from Velo3D's technical sales engineers. So now let's see exactly how that works. Let's meet our speakers. Our first speaker is Roberto Esposito from Velo3D. Hi, Roberto.
Ciao Davide, thank you for your invitation.
Thank you. Good to have you here. Roberto brings over 20 years of aviation, energy, and oil and gas experience. As Velo3D's Director of Sales in Italy, he leverages his expertise to help drive the growth of Velo3D's fully integrated solution. The next speaker also from Velo3D is Ricardo Tosi. Hi, Ricardo. Okay, sorry. Hi,
hello, everybody. Nice to have you here. Ciao, Davide.
Hi, ciao. And Ricardo is technical sales engineer at Velo3D. He assists engineers and organizations in maximizing Velo3D's technology for critical applications. And then we have from Avio, Alberto Campi. Hi, Alberto.
Hi, guys. Good afternoon to everybody.
Good afternoon and good morning to our American participants. Alberto is the leader of Avio's Additive Smart Factory and Additive Technologies, where he is responsible for the industrialization of additive processes and products. So, before we start, just a couple of service announcements. This webinar is going to be recorded and you will automatically receive a link to download it. On the right-hand side, you will see the presentations and other materials that the speakers have made available for you to download. In particular, in this case, you will see an ebook that is available both in English and in Italian. We want this to be as much as possible an interactive and informative session. So you're all welcome to ask questions that will be answered during the panel session or at the end of the discussion. Please write your questions in the chat window on the right-hand side of the screen, and we will answer them when we get to them. And with all the introduction is now over, let's make some space for Velo3D's state-of-the-art metal AM technology. Let's get to know this technology a little more and why so many state-of-the-art space companies use it. So I will start with you, Roberto. Can you give us an introduction on Velo3D and its AM technology?
Sure, Davide. Thank you. So, Velo3D, let's do a very short introduction about the company. You see on the screen, on the slides, our founder and CEO, Benny Buller. The company was founded only in 2014, so it's probably the last arrived on the market from what concern 3D printers producers, let's say. The company is public since 2021. And this, let's say, since we are talking about space, put on us a booster, let's say, to accelerate our growth. That was incredible in the first years in the US. Then, starting from 2021, end of 2021, we started to build the team in Europe. And today, I'm covering, let's say, North and South Europe. There are other colleagues that are covering Central Europe. And we are present even in Middle East. So this is the real first step to expand the business outside the US. As said, it was a young company. Our main focus is our, let's say, technologies based on laser powder bed fusion. There are many other technologies in the space of additive manufacturing. Despite this, for sure, laser powder bed fusion is today the largest used technology. Why? Because it is possible with this technology to print complex geometries and parts, even, let's say, for very critical mission components. That is still not very possible with other technology. And you see here some data for sure. The selling of the laser powder bed fusion hardware is growing since the, let's say, the past COVID, we can say, period is continuing to growing, following what was the trend of the previous year. And as said, we are active in this sector, in this technology. Here in these slides, what we can offer to the market today, our machine are named Sapphire. We have today just 4 types of machine. This is even easy very easy for the customer to use them because the process and the software that we use are exactly the same. The process was just scaled up from the small Sapphire that you see here on the screen, the big Sapphire, the last one on the screen. All our building chambers are cylindrical, as you see. The small Sapphire has a diameter of 315 millimeters by 400. We can arrive till 1 meter. And the two small machines are equipped with the two lasers of 1 kilowatt laser. This is always very important in terms of power, even to deal with more complex, let's say, materials. The biggest machine are named always Sapphire, XC, and XC 1 meter Z are the, let's say, the technology that we use today, especially for production reasons. So to scale up the use of additive manufacturing to the next level, that is not anymore prototyping, but make serious production with these machines. Since we have today here Avio has in its portfolio 2 machines from us today. That is the smallest one, the Sapphire, simple Sapphire, and then the biggest one to print, as we will see, extremely big components like big combustion chamber. The big machine are equipped with 8 lasers. We are usual to work with layer thickness that are going between 50 and 150 micron. Our standard process is with 50 micron, and this is what is differentiating us from the competition. Essentially, thanks to this process, let's say some of great achieved, obtained by our founder, we are able to print surface that before were impossible to be done, let's say, in additive manufacturing, since from physical standpoint you were constrained to use, you were forced to use supports. Now, in our case, many times, thanks to this velo process, we can skip or limit the use of supports. This enlarge a lot the adoption of this technology to print even components that before was very impossible to be printed in additive manufacturing. Another great, let's say, achievement our founder for our technology is the fact that the machines are automated, calibrated. What does it mean? Means that essentially we can always be sure that our machine, despite who is going to use them, where they are sitting, who is the operators, are going to give exactly the same, let's say, result. And this is thanks to these 1,000 sensors that are equipped in the machine, and the let's say, calibration protocol that told our machine are following automatically without, let's say, any action from the operator. We said about the benefit, about the fact that we can limit the use of the supports. This is another great part of the technology. From software standpoint, both the build preparation software and the quality validation software that we will see in the next slide that we call Assure are both designed and developed by us. This means that you can always be sure to receive always the latest release of this software, to be always updated with the last, let's say, revision and new features that we are going to incorporate inside the software. In particular, one important feature of Flow is the fact that we are not working with STL file as normally in additive manufacturing happens. We can digest directly the CAD file imported by the customer, whatever CAD, whatever software they are going to use. This is quite important because it means that not to avoid losing any information that is incorporated inside the drawings coming from the customer. And this is one of the reasons why we talk at the end with our build preparation file. We name it a golden print file, because at the end is a file that independently, as we said from the beginning, from who is operating the machine, is going to give the same result wherever we are going to use it. Assure, another important fundamental, and my customer Alberto knows very well, the report that is going out from the machine together with the components that we are going to print is extremely important from the certification of the part we are printing. Not only, the software is going to control the machine, making the auto calibration and following a routine to be sure that the machine is able to stay, let's say, in spec with all the parameters, the printing parameters. On top of this, the software is able to follow the process, the printing process, layer by layer, giving, let's say, essentially all the information that related to the part that is under printing from layer 1 till the last one. You will have this Velo 3D Assured Build report that is always released together with the components, and inside, as said, you will find a lot of information precious to arrive to the certification of the part. Materials, another important aspect. Let's say we started with them, essentially since the company started with the space, we can say today Velo 3D is covering more or less all the private space market in US, from SpaceX, Launch, Relativity. All the main private companies are our customer. They have our machine to produce space parts. This was extremely important even for the materials we developed since the beginning. You can recognize here for sure the nickel alloy. Inconel 180 is one of the most used in space application today. You can see the second line, the GR-COP 42, another great candidate to become a very used material in space, and Alberto will say much more about this in his presentation. Same for C18150, so another copper alloy used in space application. We have then other, of course, a nickel alloy like the Astelloy family. We have the aluminium F357 is another material very used in space, like the T64. Less, of course, the stainless steel 1.5 and the steel M300 that are for other applications. But this is to say that we are covering essentially, based on the application, based on the segment, essentially more or less all the main important alloys available on the market. And this, as said before, we started in space, and you see great customer in space, especially US, but today we have even Avio in Europe. We have many players in defense, aviation and defense as well. It is very important to highlight the last line. Many times can happen that the customer doesn't want to purchase machines. They want to use, let's say, contract manufacturers or externalize, going outsourcing to print components. And this is very important for us too. And this, you can see here some of our partners. There is even an Italian one today that is CS, still not mentioned because they are going to receive their machine by January next year. But these are the companies that can print essentially for our OEMs, final user, that they don't want to purchase a machine to make this big investment. And this is the contract, what we call contract manufacturing. We said the complex part. Space is for sure. It is very important for sure in space, the geometry of the part, the reduction of the weight, the speed to receive essentially the part. And here you can see very complex geometry. On the left side, let's mention just the ones very used in space for the moment. You see a complete turbo pump, completely printed, 100% printed in additive manufacturing. That is very, of course, a critical mission component for space application. This was completely printed in additive manufacturing using our machine. You can realize a more compact, for sure, turbo pump. This means reduce the weight. This means have more space for the work, for the payload, essentially. In the middle of the slide, you can recognize a combustion chamber printed GR-COP. You can see even the volute of another turbo pump. You can see the injectors of put on the top of combustion chambers printed in nickel, in Inconel 718. These are for sure probably the most important components today printed in additive manufacturing, but there are many others. And talking about big components, because for sure space is going in this direction, no? The space company needs bigger and bigger components. And this is what we printed last year for Avio, is the biggest never printed worldwide combustion chamber in GR-COP 42. Just to give some numbers about this, you see here Giulio Ranzo, the Avio CEO, we were in Le Bourget to expose this part. This was 600 millimeters in diameter by 1 meter in height, in Z. So it was for sure the biggest part never printed in these materials for space application. And I think now even Ricardo can give us some more technical contribution about the discussion.
So thank you, Roberto, for passing over. I just want to start from there, from what you said about materials and the future of IM in space, which we can say is the bright future of IM in space. What is next? We are going, what we are getting today, what we are looking for. So there are lots of questions, lots of companies, they are starting up new businesses, but what they are really looking for from companies, they have like a very small payload, or the one they are wishing for very big payloads. But the most common words for them is 3D printing, additive manufacturing. What they are aiming, small parts, large parts, all of them, they are targeting to use additive components mainly for reducing the weight, which is definitely one of the advantages. And then you can also tailor your parts directly on the aim of whatever you're aiming. For example, like satellites, depending on the mission that you have to do, you can customize your satellite using 3D printing parts. The time to market is definitely much better than the past, since the production can even take like in a week time if the design is in final stages. So what next? For sure, more parts that will be on the market, different sizes. As Roberto said, turbo pumps, they can have like a very high payload against the weight, so reduction in weight, but great payloads. Main combustion chambers is another great area where it's one of the most delicate of the engine itself, where you can find very thin walls and cooling channels that will function of cooling the engine part during the action. So these are one of the best parts to be made and complex part and worth to try in additive. For material wise, those parts can be made like in Inconel. We have seen, but other material have been used, like Jarcop, like Roberto was saying, Jarcop 42, which is a copper-based alloy, which increased like the performance of the engine due to the properties of copper for high conduction. Other multi-materials have been used in parts as well, but also large parts. I mean, we are getting bigger and bigger, combining components. So laser pedal bed fusion can go even to the next level. Even following DED, of course, directed energy deposition you can aim like meters of parts. But in laser pedal bed fusion, you can have very high quality on components and near to shape parts that can be used very quickly to even do tests. A lot of companies we see, especially in the US, they try to make components and test fire them very quickly so they can assess directly the outcome of the design itself, doing like a short run of printing and then a fire test, ground or even in the sky, just to assess the quality of the components. So it's definitely a fast-paced industry for this run to space, but it's not just space, but it's also orbits. So because the business changed since the past years, there is not just going to the moon, observing like just out of the space, but there are other businesses, not just defense, but also tourism, satellites, even digital interaction. So this is driving currently what we are currently seeing.
For example, Ricardo, you can mention even our collaboration with the launcher. No, we did for them some components for their orbiter, the satellite transfer vehicle they realize. And in this, for example, application, we did the parts in aluminum. They did, using our machine, parts in aluminum, the thruster bracket, the thruster manifold. They did the tank in titanium. They did the combustion chamber and in Inconel 718. Probably it was one of the great example of, let's say, where our technology found a large of application of components really printed, because then this orbiter was already launched by Launcher, that today is a vast company in the past months, let's say.
That's correct. Increasing number of parts are currently on the market due to the complexity. That was a real case where a different material with different geometry would be applied in the satellites. That was an excellent case study brought from there in the market.
My favorite components remain this turbo pump that we showed at Formex let's say in last November, and was fantastic because it was extremely compact. There are so many parts. You see even some impellers here that you can probably recognize inside the machine, the pump itself. But there are extremely complex to be done, and many of these we did without, let's say, supports. The reason why we were able to do in this let's say geometry, in this shape, so complex and so compact, was even due to the fact that our technology can reduce the use of supports.
Guys, thank you very much. Sorry, we're going a little bit long on the presentation. I wanted to ask a couple of questions to you guys, just to understand. Do you think that the future is, larger parts, more materials, or what do you think the future of additive is in the space industry? Roberto. I'm sorry, Ricardo. Sorry, this question was actually for you, Ricardo. Go ahead.
Doesn't matter. So I mean, for sure, we're gonna see larger and larger components coming up. High complexity, more performance. Geometry is very optimized, even multi components together, and multi materials. Also, material-wise, space is very active since they have this advantage of not having people on board, at least for initial tests, I would say. So they have this advantage on trying new materials. There are already some very high-performance material that have been used, but there's still like a kind of standard-ish 3D printing. I see like a new tendency of material coming up. The development will take place from now on, I believe. Of course, as usual, it's still working in progress, but I see a lot of push indeed on new materials and bigger parts, very high performance parts, pushing the boundaries as usual.
Thank you. And Roberto, back to you. This is the question I had for you was from a space application point of view, what are the requirements that you get from space companies? I mean, what is it that additive manufacturing, and in particular the Velo 3D technology, can do that to help space companies, advance?
Yeah. So today, for sure, the easy answer from why to use Velo 3D for space application is essentially for this extremely flexibility in the limitation of the use of supports that put the customer in the condition to print a very complex geometry. When you will see a combustion chamber at the end, if we give a look, it is a very simple part, but it's just apparently that is like this, in the sense that inside of the walls there are very thin walls, but there are even cooling channels to cool the combustion chamber itself. So the complexity of the geometry can help a lot. The dimension that we can give to our customer, the benefit to print a part of today 600 millimeters in diameter by 1 meter, and we are working to give more to achieve even bigger, let's say, dimensions. The materials, very important, as said by Ricardo. You can play together with different nickel, Inconel 718 on top for sure, but copper is going to be used a lot, and we are already prepared to give this possibility to our customer. And then for sure, our machines are very fast. At the end, we have a machine with 8 lasers. This increases a lot the productivity. Let's say that is another aspect very important to be considered when a customer is going to select our technology. For sure, additive manufacturing for space is probably the best application because the volume of components to be printed are low at the end. We are fast in printing. We can do complex geometry. So there are all the ingredients for this segment to increase the number of components to be printed, let's say, in additive.
Thank you. And I have one final question for you, Ricardo. what is it that Velo 3D does specifically to help companies, additive manufacturing their processes more easily?
Yeah, so business strategy is always the most important one. It comes ahead of everything. So in terms of business strategy, most of companies, they like to try 3D printing and additive to make their own parts. Some people, they've experienced, some they don't. Some people, they come to us just to make the first prototypes so we can help them towards the additive design until they're gonna reach like a good status in their design components, and then for first initial tests. And then for the printing, we can also help them, since we have this contract manufacturing network in Velo 3D, so they can print with our partners, so we can really help them hand by hand to go through from the design stages to the final component. So our plan is making the customer successful. So this is what we're currently trying to do as best at Velo 3D.
Fantastic. And let's hear it from the customer now, if we can. I know we have a lot of questions for Alberto too. So I would like Alberto to ask you I know you have a presentation for us. I also have a couple of questions for you on exactly if you can, to understand why you decided to invest in Velo 3D machines, and if you can help us understand a little bit more about, the history of the company and, what Avio does.
Okay. Thanks, David and Dr. Marter, for inviting me. It's a pleasure for me and David to be here today and to show just a part of the work that we have been carrying out in the last 2 years on our additive smart factory. I will be very quick with some words about my company because you already did it very well, to be honest. So Avio is a space propulsion leader with a long tradition in engineering, chemistry, and advanced materials, and with over 1,200 employees located in Italy, France, and French Guiana. We have more than 100 years of history, during which the company has been playing a key role in the design, manufacturing, and integration of space launcher system and tactical missiles. There is a banner on the presentation, if you can remove it.
Yeah, I think I think you don't, viewers don't see it.
Okay, it was just for me, sorry. Okay, so thanks to our cooperation and collaboration that you described before with university research centers and technology partners, Avio operates development activities to create cutting-edge technologies and products with the constant aim to shape the future of space exploration. Additive is one of them. Avio, as you said, is prime contractor for the Big A family and subcontractor for Ariane EV lift launcher. Our future in terms of transportation system are for sure Big C and Big A launchers. In particular, with Big A, we will accomplish to have a liquid propellant engine, the M10, mostly additive manufactured, realized, integrated, and tested in Italy. But before to focus on the M10 engine, that is in the framework of additive manufacturing, let me say, David, the main character of this presentation, I would like to show you a short video that summarizes better than my words our company, and I hope you enjoy it.
Thank you. Yes, we can start the video. If we can go back to, there we go. Thank you. I'm sorry, Alberto, your microphone is off.
Okay, thank you.
There we go.
Some words about our M10. M10 engine is a green engine with reduced environment impact of the launch activities. It's a cryogenic 10-ton class engine. It's an engine for a third stage engine of the VGA launcher that we say. It will pave the road of a new generation of launchers with the goal of increase the competitivity of European small launchers. While we are talking about M10 so specifically, because from M10 we are going to jump directly into his manufacturing technologies with this almost additive manufacturing. And without taking up any of your I will start with the presentation of our additive smart factory and the approach that we have been adopting since the last 2 years. With the scope, the main scope, to be process owner. So Avio has decided to internalize additive manufacturing as a key process in terms of product and technological know-how. In this framework, we invested on Velo machines as key machine in the Avio Smart Factory, but not only. I'm sure we will have time to talk a little bit more about Velo machine, but let me show first the other machines of the factory that are important to complete the process. So the approach starts from material characterization to the process itself, the ancillary phases of the process, that is ultrasound washing, depowdering, and so on, and controls, checks on samples and on the part. So we want to close all the loop and to be owner of the entire process, not just the printing process. And so that's important for us. I show you here on the next one some numbers of our facilities, where it's even showed a cycle for additive manufacturing. So the scope was to internalize everything. The only thing means that we are evaluating to internalize, but not for the moment. It's autostatic pressing furnace that, as we know, it's a key process after printing in additive manufacturing. So apart from that, we are going to close the loop inside our factory. Along with the productive site, we are realizing a metallurgical lab for the scope that I mentioned before, so to close the loop and to have fully capability and control of on the process. So from powders test to the components acceptance phase. I go fast on that. We already procured instrument for determining the chemical composition to do on the powder, on the samples, metallography, micrographic inspection, surface texture or roughness, as we want to call, and powder density and flow rate. Last but not least, a special mention to our CT scan. It's a big investment for our company. And we decided to do it, first of all, because we want to take advance from the know-how in terms of non-destructive inspection, NDI, that we already have in Avio. Because in Avio, we had an NDA third-level specialist. The control is also important, not only because it's prescribed, but the ECSS, basically the rules that we have to follow in the European space. But also because it gives us the possibility to fully understand and control the process during the various phases of the manufacturing. So I hope I didn't annoy you and not out of time, and I will like to close this presentation with a quick eye on our facility. So on the first column, you can see the XC Sapphire 1 meter Z on the top, and on the bottom, the Sapphire, the classic one, the small one. On the central row, we have the ultrasonic washing machine manufactured by Welding-Free, that is an Italian company, and two depowdering machine in order to move and vibrate the components and try to recover as much powder as we can after the print. And then on the right, ADM cut machine and a small additive machine for laboratory and research purpose. So with this slide, I close my presentation and I give you the word, Davide.
Thank you. And the first question that comes to mind is why exactly, why did you decide to turn to the Velo 3D solutions?
Okay, as I told you, Avio decided to internalize additive manufacturing, and Velo machine are considered key machines, key assets on these new factories. Which are the reason? First of all, like Roberto and Ricardo said very well before, the increased building volume size. It could appear like a simple motivation, but for us it's important, and I will show you. Thank you for moving the slide. I will show you why. So this is a mock-up of our M10 combustion chamber. It's a part that right now we realize in two parts, because at the time we started the development of this part, we have not machines like that on the market. So basically we had to realize the two separate parts that are the cylinder section and the nozzle sections, and then weld together. So you understand that even if it's a traditional process, it's still a special process, welding. So and moreover, in an area where the thermal flux are very high. So Velo machines will allow us in the future to overcome the risk of the traditional manufacturing process, such as welding, and realize a single component without any welding joint on critical portion of the part. So it's not. So it's really important for us. Then what drove us on the procurement of Velo machine. For sure, an excellent combination between part surface quality, mechanical properties, and overall process control that Roberto showed before with Assure, along with the short process time that increase the production rate, as we know. So those basically are the main two reasons. Yeah.
Thank you. And we have a question that actually a lot of people asked us. We catch two birds with one stone here. Parts. We saw some of the parts you are making now.
Yeah.
Can you give us some more information, some more details about the parts that you intend to make in the future?
Yeah, thank you. Thank you, Tom, for your question. So, we start to see some of the part that we are going to realize. Basically, we are talking about engines functional parts, so combustion chamber chassis, that was big part printed on the XC, and turbo pumps and valves components that we are going to print on the medium size, on the small Sapphire. But the goal, so those are part of the bigger M10 engine, but the goal is to extend the technology to other metal components. So in this slide, you can see a mock-up of the combustion chamber single part. You can see on the bottom part turbo pumps like volute, and that's a volute, and even a copper subscale chamber.
Fantastic. And then my last question, then we will go to the audience questions, which are quite a few. My last question is some more details about which parts of the Vega rocket that are being printed, and what the process looks like.
Like I said, we are talking about right now M10 of Vega launch, basically, and developments. So when I talk about developments, I'm talking about technological demonstrators paving the way to next generation of launchers. So that's the two bigger harms on where we are working on. But like I said, by using nickel alloy and copper alloy. Like I said, the scope is to extend the technology to even to other programs and even to other launchers.
Fantastic. And there is really so much to talk about. Honestly, I think these are some of the most fascinating applications in additive manufacturing by far. And really, we're seeing so much happening in this space. So we will take some questions from the audience now, if that's okay. And then you guys can tell me who wants to answer each question, if it's a question that more of you can answer or not. If I can guess who the best person is, I will say it. So the first question that we have is, how long does it take? And I think this is for you, Alberto, but also you Velo3D guys can also give us an input. How long does it take to optimize the processing parameters?
Okay, I didn't see the name of the person who made the question.
Oh,
but
sorry.
yeah. No problem. Just to thank him.
Okay.
Just to thank him. So we are lucky with the Video 3D machines because the parameter is embedded on the material, on the specific material that you are using for the part. Then you have, of course, the freedom to arrange and optimize some sub-processes on the part. So this is a process that it can take, considering even the qualification of the product and of the process, it can take 3 or 4 months. It depends on the part and on the complexity of the part. I hope I answered this question.
Yeah, I don't know if you wanted to add something, Ricardo, or we can go to...
Yeah, I mean, Alberto is very prepared, to be honest. So yeah, we basically Velo comes with optimized parameters, since we have some sub-processes in the system where it allows to unlock low angle skins and other features. So these are embedded in the software, and then we have our own software called Flow, where you can even tweak the parameters to optimize depending on the design, the design that you have. And in case the customer cannot reach the level that they want to, they can always ask us and some supports. So everything presets to help the customer to don't spend huge time on development in R&D. But it's more like for production. So the system should be basically ready to print the parts after the preparation in the software.
Makes sense.
On supports and orientation, not much more.
Yeah. I have another question that Alberto, you showed the workflow of the additive factory, all the different stations, and you mentioned the CT scan. Is that the only NDT that you use, and were you able to CT scan the full size of these parts?
Can you repeat it? If we are able to CT scan
the entire part, and do you use
okay.
other NDT systems?
I will come back to the slide. Yes, we are able to scan the biggest part that we can realize with the XC Sapphire 1 meter Z. So we are talking about a meter part with almost 600 millimeters of the main diameter. This system allows us to combine the classic CT scan, okay, with a surface geometrical reconstruction. So this is in order to eliminate the noise of the CT scan. Right now, I think that this is the most reliable system to inspect additive part, but that's on the part. Then we have other kind of check that we are going to perform on the samples, destructive and non-destructive. And even this system to understand if part comes out with defects on the internal surface, if there is any powder trapped on the channels that you can see, as Roberto described before. So right now, this is the most important one that we are going to use.
And kind of connected to that, what are the powder bed quality parameters that you can monitor through in situ monitoring? And again, this is, I think, to any of you who wants to answer.
I think it's more for Vilo, but I mean, at least an introduction I can answer because we are using the machine, so we know which kind of parameters. The most important one that we are going to check during the printing is the presence of protrusion on the powder bed. So this is very important to us, even if we want to relate a possible defects to that specific layer. So this is for me and from the customer point of view, one of the most important. Then there are other checks that Velo can explain that can be done before to start the job. They served as a calibration checks, but even some checks on the functioning of the other parameters that are very useful too.
Yeah, thank you, Alberto, for the introduction. It is completely correct. So we have like a very smart system that monitors the machine during the print. Since we have a non-touch recoater, we have some sensor that allowing to check the spreading of the powder on top and the eventual protrusion that can happen during the printing, the lasing. We'll say, since it's quite aggressive, sometimes even in tight angles, we need to keep always an eye on the print, but also other sensor like the calibration of lasers, oxygen, and like basic or even advanced one are used, that at the end generates a report. That this report is normally used to check the conformity, reliability, and consistency of the part after the print and throughout the production.
Thank you. And another question, this is more for Alberto, is how have you designed these parts? And in particular, they're asking if you used any AI tools.
Not for the moment, to answer to the last part of your question, but the goal of the scope of the factory is even to integrate real world and digital world. So I thank you for this question. So I can show just a slide. Let understand what is our scope with, of course, with our smart factory. So it's a parallel object, not less important, and this, like I said, an integration between real and digital world. This will allow us to collect most of the big amount of data produced during the global process in a unique central data management server, and to elaborate them in order to have proactive actions on the real process. So as this big amount of data can be managed by an AI, it's not the time for now, but for sure we are going to investigate on
it. There's a question related to that, so I will ask it if you use lattice structures inside the components, and if so, if you have challenges in depowdering.
Mm-hmm.
Okay, I cannot really answer to this question because I
can answer that if you want, but in general terms.
If you want to save me, yes, Ricardo, please.
So yes, it's a common challenge. The more complex you get, especially in intricate channels, more difficulties you have on the powdering. Of course, nowadays there are like, I don't want to say tricks because there are not many tricks. The powder flow is, I don't want to say common knowledge, but is kind of known. So there are like processes like the powdering unit stations that they can definitely help on the powdering parts. But we are not hiding that a lot of customers face these challenges and they ask us how we can support them. So there is a real study behind it. Is more we are pushing also boundaries on pushing powder out of the parts.
Yeah, I cannot answer about the kind of support, of course, but like Ricardo said, it's a crucial point, and we start to think about it even from the early design phase. So the design come up, of course, with the properties that the functioning of the part, and that's for sure the requirements of the part and of the material, but an eye on the way to recover the powder, to get rid of the powder, is also important since the early design phase for us. And
this is also for more for Velo 3D. What is the build rate of in centimeters per hour of the Sapphire XC1MZ, and with what layer thickness?
Yeah, this is a good question. I mean, it's difficult to answer because this really depends on that you use, the parameter set that you use, and the component itself. If you have like a very thick components, you have a lot of lasing per layer. If you have a very thin, tall components, the position rate is going to change. So also on the system, we have a 2 laser and 8 lasers. So the 8 laser big XC machine is definitely much faster. So if you would like to have more information, you can find more on our website. So targeting the material itself that you have in your mind, and then is related to the system itself, so you can have an answer.
Thank you. And I have another question more for Alberto, but maybe you can also give us an input on sourcing metal powders. Is that a key requirement in the success of your printing, especially for position specifications such as the GR-COP 42?
Yes, of course it is. It's the first phase, and it's let me say the main ingredients along with the process from which depends the properties of the part that we are going to realize. So, of course, we issued an internal specification that is going to cover all the requirements of the ECSS, European Space Agency specification, and even ASTM, specifically for nickel alloy. Even for GRCOP, it's also important. So we work along with powders supplier in order to understand if some slight modification on the chemical composition can help us on obtaining higher properties. Yes.
Yeah, powder is being studied since like long time, fortunately, and there are lots of standards that can be used and a system to really analyze the powder. But Alberto raised a good point. You can have the best machine in the world, but if you have a bad powder, you can't go anywhere.
Absolutely. And how do you qualify a new material for the Velo?
So normally we go in-house. So like Alberto and most of the customers do, they have like a minimum spec, like standards that is used in additive. So we start with the standard, and then depending on the powder, normally we qualify the powder in-house. So we can certify the powder. So there is a procedure that it can take from some weeks for a few months, depending if it's the powder similar to what we have in-house. If it's a new powder, for example, there are customers that are interested in a specific powder. So we work along with them in case they would like to use our system with that powder. So depending on the angle of the request, but it can take from a few weeks to a few months.
Okay. One thing, I have a few questions on machine capabilities. I will ask them all together. One is if you can do part repair in some way with Velo 3D technology. Another one is if you can do hybrid printing, but I'm not sure if they mean hybrid printing as in additive and subtractive or hybrid with different materials.
I guess the second one.
Probably
both. Yeah, so it's a very open topic. I mean, there are a lot of developments these days. I come from a background in academia, so I've seen anyhow of those. So it's something that is happening. I see application that there are some repairings, some multi-materials. So repairings is the aim is like, is it worth really to repair the part or not? Is going back to the cost, to the business case is always the case. So you need to go back to the origin. Can I afford this or not? Does it take any value? And this for the repair case. For the multi-material technologies that make multi-materials directly embedded in the system, currently Velo doesn't do multi-materials. We offer multiple materials, but once at a time.
Okay, fantastic. And I have just one very quick last question just to close as we are out of time. I wanted to ask you, Alberto, what do you see for the future of what kind of future opportunities do you see for Avio today? You know, where do you see the biggest opportunities for the company in the near future?
For sure, Davide, the possibility to explore complex geometries is one of them. You know, for a product like ours, I mean, find the good compromise between geometry and the properties of the part is crucial. So the possibility to quickly realize, design, realize, and test a part for sure is going to speed up our growth process. Then for the future, I see large part, yes, more parts for sure, and new materials, we hope.
Fantastic. And thank you, everyone. This is all the time we have for today. It has really been a very informative and lively session, and I encourage everyone in the audience to reach out to the Velo 3D team, or but you can click on the contact information on the screen, or visit the website at www.velo3d.com. Thank you very much to all the great panelists, and thank you all for joining us today, and see you next time.
Thank you, everyone.
See you next time. Bye.
Bye. Thank you.
Bye.